Hello and welcome back. In this segment, we're going to look at something called selection, or the if-else statement. Up until now, in all of our programs, we've been using the control structure called sequence. And sequence is really very simple. It means the program starts to execute at the beginning of the main function, and the lines of code execute in sequence, one after another. Sometimes it's useful to selectively execute lines of code. And we need a way now, if we're going to selectively or in some conditions execute lines of code, we need a way to express a condition that would make a decision on whether or not to execute some lines of code. So in that case, we're going to introduce relational operators here, and there are 6 of them. The first 4 you should be kind of familiar with: greater than, less than or equal to, less than or equal to, and then the equalities, equal to and not equal to. And notice that the symbols that we're going to use for these operators, particularly the equal to operator, is 2 equal signs. And that's why we've been pronouncing the assignment operator gets, which is 1 equal sign, so that you'll have a better distinction. So this is what we're going to use for equal to, and it will prevent you from making some mistakes if you call the assignment operator gets. Okay, so how do we use these relational operators to express something that would allow us to make a decision? For example, 10 is greater than 5. Is that true or false? Try not to say yes or no. Say true or false. So 10 is greater than 5. We know that that's true. A is less than or equal to B. So in this case, we're comparing the values that are in the variables A and B. And we don't know what's in A and B here, so we don't know if that one is true or false. So 6 relational operators: greater than, less than, greater than or equal to, less than or equal to, and not equal to. So these last 4 that require 2 keystrokes to make the operator, they have to look like this: the greater than sign followed by the equal sign with no space in between is the greater than or equal to operator, and so on for the remaining. Okay, now let's look at the if statement in C. And we have relational expressions that we create using the relational operators, and they will evaluate to true or false. So we're going to look at how to make an if statement to selectively execute some code. So here's the general form. We use the keyword if, lowercase as usual, and then a relational expression inside of parentheses. So if something is true, then do this. Let's try this in C code. Okay, so here we are in the development environment, and I've created a new project called selection, and I've made an empty C program with a main function, and the usual that you should be expecting now. If you'd like to pause this and get caught up to this so that you can type along with me when we exercise these relational operators and if statements, that might be a good idea. So let's start working in this main program, and I'm going to first of all just write the simplest possible if statement so that you can see what's going on. So this is always going to be true about an if statement. We have the keyword if and then parentheses, and inside here we're going to express the condition. So here's a very simple condition that we all know to be true: if 10 is greater than 5. Notice that when we hit enter after this if statement, the editor helps us by indenting automatically. So the indentation is going to indicate which lines of code are controlled by the if statement. So I'll just write a printf statement here. We know that 10 is greater than 5. And a \n, which is the carriage return. and the semicolon at the end. I don't have very much room to work here, so I'll make these a little bit smaller. So what we've done with this if statement, we've said, if this is true, then do this. There is no keyword then in the C language, but we can think of it that way. If this, then do this. So if we run this, let's use F7 to build it. And we see that 0 have failed and 1 succeeded, and then we can push F5 to run it. And it does execute the printf statement and outputs, we know that 10 is greater than 5. So let's change this. If 10 is less than 5, is that true or false? 10 is less than 5 is false. So this line of code will be skipped. Let's recompile with F7 and then run this line of code, and you see that the program doesn't output anything, so the printf statement did not get executed. The rule is that a printf statement, or an if statement will control one line of code or one compound statement. One statement or one compound statement. So what if we wanted to have a couple of lines of code controlled by that one if? I don't know what to put here. Just for concepts, here's another line. Excuse me. Now what this looks like is that the if statement controls both of these lines of code, but it doesn't. It only controls one line of code or one statement or one compound statement. So we can make a compound statement using these braces. So now the indentation is correct. So if this is true, do all of this inside the braces. If this is false, don't do any of it. So we have now a flow of control where some of the lines of code will be executed and some won't. So this is what we mean by selection, or selectively executing code. Let's declare a couple of variables. Let's make an int a and put 34 in it, and a b and put 132. I left off the assignment operator. Now we can write if statements using a and b. So if a is equal to b, let's write out a is equal to b. So do you think that these lines of code will be executed or not? If this is true, do this. A is not equal to b, so I'll suggest that these will not be output, but let's try it. F7 and F5, and the program ran and didn't output anything. So let's try another operator, a relational operator not equal. A is not equal to b. Is that true or false? A is not equal to b is true, so these lines of code will be executed. F7, F5, A is not equal to b, and here's another line just for fun. Okay, so there's the general format of an if statement. It controls one statement or one compound statement, and inside the if we would write a relational expression or an expression using a relational operator to determine whether these lines of code should be selectively executed. Well, you're going to get tired of me saying this, but it is a sticking point for a lot of beginning C programmers, so we're going to look once more at what these braces mean with the control structure. So the control structure that we're using, our first one, is the if statement, and the if statement controls or decides whether to selectively execute one line of code or one block of code. You might say one statement or one compound statement. And these braces are used to decide which lines of code would be controlled by the if statement. So in the example here, we have if A is greater than B, then C gets 27 times B, and then an output statement A is greater than B. So this is all nonsense code. I don't know why we're multiplying 27 by B, but we're only doing it when A is greater than B. So the braces are used to indicate which lines of code are going to be executed or not, depending on the truthness or the veracity of the condition in the if. When the if statement is required to control only one line of code, then the braces are optional. Some people like to use braces even when there's only one line of code to be controlled, but it really doesn't matter if you use them or not. And there's no strong convention in the C language as to whether you should use them when they're not necessary. Let's move now to using the if-else statement. So an if statement may or may not have an else clause associated with it. In this situation, we want to do something when the condition is true and something else when the condition is false. So one or the other, never both. So for example, this is not C code, just an example of how to express the logic. You might say if milk is greater than 0, then drink some milk, else go buy some milk. So you see that the if and the else are dichotomous. Either you do one part or the other, never both. A relational expression can only evaluate to true or false. There's nothing in between, and it can never be both. The easiest way to understand the if-else statement is to just look at it executing in the development environment. So we're going to go back there now and look at the rules for how to express an if statement that has an else clause and all of the associated issues with the braces and how to control certain lines of code using the if and else statements. Here we are back in the development environment. This is where we left off the last time. We were executing if statements with relational expressions, and when these evaluate to true, then we'll execute some code. If they evaluate to false, then we'll skip them. So if this is true, do this. And what we just introduced in the PowerPoint slides is the possibility of an else clause. So let's take if A is greater than B. Is that true or false? If A is greater than B, it often helps if you just put numbers in here and read the numbers. So if 34 is greater than 132, false. So we won't be doing that part. Now let's add an else clause. A is not greater than B. So now we have an else clause, and look at the style here. This is not a required style, and the textbooks that you're using or other code samples in C may not use the braces using this style. But this is one of the acceptable ones in C. So we have the true block and the false block. So if A is greater than B, and we said that that's false, where will we go next? We'll go to the else part. And if we compile and execute this, F7 and F5, it executes the false part. A is not greater than B. So we have selectively executed this line of code and selectively not executed these two lines of code. And these braces and the style, some people get really hung up on how the braces should be written in C. Some people prefer that the braces, open and close brace, go on their own individual lines, and that this is an easier way of looking at it. If you have an instructor or a boss who insists on one style, then you should use that style. And in the workplace, in a group, you would use the style that your workplace is using. So someone will dictate the style that you should be using, and I'm going to use my preferred style, which is one of the acceptable ones in C. So now we have an if statement with an else block. Well, what lines of code can go in the if part or the else part? You can put just about anything you want in here, and including another if statement. So what if I put here, if A is greater than 30. Now let's put a brace. The indentation starts to be very important because the indentation kind of shows you or helps you as the reader to see which lines of code are going to be executed. So let's put a printf statement in here and we'll look at the flow of control. A is greater than 30. Most people expect that there would be a blank line just before the any if statement, and that's not a requirement of the language, that's another style issue. So what is the flow of control we have here now? We have A is greater than B. 34 is greater than 132. True or false? Well, that's false, so we go to the else part. Now we're going to execute the else part in sequence. So we'll do the printf, and now we come to another if statement. If A is greater than 30, is that true or false? 34 is greater than 30. That's true, so we will output this, A is greater than 30. These can be arbitrarily complex. We can put an if statement inside an if statement inside an if statement. This is called nesting ifs. We can put ifs inside of elses. This if statement could have an else associated with it. The rule of thumb is if your code is getting too complicated for someone else to read easily, then you should rethink your solution. So I made this just a little bit complicated to show you that you can have if and else statements inside of if and else statements. And it gets kind of fun to watch the logic execute. So let's execute this one and make sure that it does print A is not greater than B and A is greater than 30. And it does. Okay, we looked just briefly at the debugger earlier when we saw a runtime error in one of the previous segments. Now I'd like to start getting you comfortable with the debugger as we start to use the selection constructs. So let's click out here in the margin, and you'll get a big red dot that indicates that we have a breakpoint. I need a little more room down here, so I'm going to lift this up a little bit. Now when we hit F5 this time, we're going to run, not execute the whole program, we're going to run up to that breakpoint. And we have a yellow arrow now, and if you hover over the yellow arrow, it says, this is the next statement that will be executed. So we have if A is greater than B. Down here we have, in the lower left, the name of our variables A and B, the current value, and their data type. So if we just look at this line of code, if A is greater than B, and now down here look at the current value in the variables, A has 34 and B has 132, we can pretty easily see that this is going to evaluate to false. But we want to see that. We want to see the program doing everything that it's actually doing one line at a time. And we'll have complete confidence that the program is doing what we want it to do. So now let's look up here. We have some new symbols while we're stopped at a line of code. We have some symbols up here. One is step into and one is step over. Step over kind of means let's execute this line of code. You don't really know why it's called step over, but for now, let's say execute that one if statement. If I click here and see where it goes next. So the pointer, the yellow arrow, should go to the next line of code that will be executed. So if A is greater than B evaluates to false, we skip immediately to the else part, and we're going to execute this line of code. Printf A is not greater than B. So let's execute that printf statement by the step over. Now we're at this if statement. If A is greater than 30, well, look down here at the value of the variables. A is 34. So this should evaluate to true. And if I execute the if statement, I would expect the yellow arrow to go inside of the if statement and execute this line of code. Using a debugger as you are developing your code is really very important. You need to have confidence, especially as a beginner, that the code that you're writing is doing what you expect. So you can look at the output from this, and we can see that, yes, certainly it's doing something, but when you look at each line of code execute, including the value of the variables, then you can see exactly what it's doing. So here's the output from that, and this executing in the debugger or walking through your code is a really good learning tool. Now I'm stuck in the debugger. How will I get out of here? Let's look under the debug menu and say stop debugging. Good. Sometimes you get stuck in the debugger and it does things that you don't really understand, and it's a very complex tool. Right now all we want to do is to walk through the code line by line and look at the value of the variables as the code executes. So if you get stuck inside of the debugger, you can do Shift F5 or look under debug and say stop debugging, get back to where you're comfortable, you know what's going on. Okay, so we had an if statement with a relational expression. Notice that the else statement doesn't have any relational expression. We're still talking about this condition. So if this is true, else do this. So the true part and the false part refers in both cases to this one relational expression, or the veracity or the truthness of that one relational expression. Now we have the flow of control, and starting to get complicated as you nest these control structures inside one another. The flow of control is more easily readable if you get the indentation correct. So, for example, if your indentation looked like this, it would start to get very difficult to read. And this is a real problem. It's not a problem for the computer. The computer doesn't look at the indentation at all. It only looks at the keywords and the braces to decide which lines of code will be executed. But the problem here is that no one should be expected to read this code. It's hard enough already without taking away the advantage that you have with the indentation as a readability aid. So, Fortunately, we have a tool in this development environment for fixing up the indentation. If you select some of the code and you look under Edit, Advanced, Format Selection, this is also Control K or Control F if you want to memorize the hotkey for that. Format Selection, and it puts your code back where it should be. So we have these two lines of code controlled by this if. These lines of code are controlled by the else. This line of code is controlled by the if and by the else. So it's indented 2 times. As a general rule, every time you open a brace, you indent 1 tab stop. So all of these lines of code are part of the main function, so they're all indented. These lines of code are indented twice. They're part of the main and controlled by the if. This line of code is part of this if, part of the else, and part of the main. So we have 3 levels of indentation there. Sometimes I say things that are very, very strong to my C programming students. I won't read code that's not indented properly. And it's pretty cheap to fix up your code. Let's see how long it takes. We can do a Control A to select the whole file, and a Control F. No, I got it wrong. Control A, Edit, Advanced, Format Selection. And I'm not sure why that Control F was in there and Control K. Let's try that. Oh, Control K, Control F. You need to use both of them if you're going to use the shortcut. I see. Well, for now, we can use Edit, Advanced, Format Selection, and the indentation will be fixed up for us so that we have something that's easier to read. Okay, let's review the concepts that we've covered in this segment on selection. Selection is when we want to execute some lines of code and not others based on the veracity or the truthness of a condition. We express conditions, conditional expressions, or relational expressions using relational operators. There are 6 relational operators in C. You really have no choice but to memorize them, or you'll get comfortable with them as we go along. Greater than and less than are 2 operators that you're very comfortable with, and I think greater than or equal to and less than or equal to you've also seen very commonly. The other 2, equal to and not equal to, the concept is simple for you, but the operators you have to memorize. The equal to operator has the 2 equal signs, and that contrasts with the gets operator, the assignment operator. And not equal to is the exclamation point followed by the equal sign. Well, relational operators compare 2 things, and the result is always true or false. And then we used if statements to decide the flow of control of the program. And this is the first time in this course that we've looked at a flow of control where some of the lines of code wouldn't be executed. If statements may or may not have an else clause associated with them. If there is an else, it must be immediately following the if statement so that the language knows what it should be doing. If this is true, do this, else do this. The if and the else either control one statement or one compound statement. And the compound statement can be created using the braces. So if we have a whole lot of code that we want to execute only if some condition is true, then we can put all of that code inside of those braces, as we saw in the examples. See you next time.